Hello and welcome. Perhaps you're lying in bed right now, the day finally quiet around you, or maybe you're simply seeking a moment of calm in the endless rush of things. Either way, this is a gentle space for wondering together. Tonight, we're going to explore a question that lives at the very edge of what we can think about. It's a question that feels almost too large to hold, yet somehow deeply intimate. What if everything we know, every star, every thought, every moment of existence emerges from something beyond our universe entirely? This isn't a question we'll answer. Some questions are more valuable for the journey they invite than for any destination they promise. We're simply going to wander through possibilities together, letting scientific discoveries dissolve into philosophical wonder, allowing certainty to soften into beautiful mystery. There's no pressure here, no test at the end, just curiosity, patience, and the quiet pleasure of contemplating something extraordinary. We'll move slowly, pausing often, making space for both the known and the unknown. You might drift in and out of focus, and that's perfectly fine. This content will be here, a gentle companion for however long you need it. So settle in wherever you are, let your thoughts slow just a little, and together, let's step toward the boundary of everything we think we understand. Before we can wonder what might lie beyond our universe, perhaps we should spend a moment with the extraordinary fact that we have a universe at all. You exist right now within something almost impossibly vast. The observable universe stretches roughly 93 billion light-years across, a distance so enormous that light itself, traveling at 186,000 miles per second, would need 93 billion years to cross it. And yet here you are, a conscious being aware of this vastness, made of the same fundamental stuff that composes distant galaxies. Scientists have identified 4 fundamental forces holding everything together: gravity pulling masses toward each other, electromagnetism binding atoms and generating light, and 2 nuclear forces operating at scales smaller than we can directly perceive. These forces, combined with a handful of particle types, somehow give rise to everything: stars burning in the darkness, planets cooling into stone and water, minds capable of wondering why any of this exists. What's remarkable isn't just the scale or complexity, it's the sheer improbability of something existing when nothing seems so much simpler. Nothing requires no explanation, no forces, no laws. Nothing is elegantly uncomplicated. Yet here we are, surrounded by intricate patterns of matter and energy, governed by mathematical relationships we didn't invent but merely discovered. Some nights, if you step outside and look up, you might catch yourself feeling the strangeness of it. All those points of light, each one a massive nuclear furnace, scattered through distances that make earthly measurements feel like jokes, and somehow, on at least one small rock orbiting one unremarkable star, the universe has become aware of itself through us. This awareness itself is perhaps the deepest mystery. We're not just in the universe, we're the universe looking at itself, asking questions, feeling wonder. Atoms arranged in such a way that they contemplate their own existence. Why these particular forces? Why these specific strengths and relationships? The electromagnetic force, for instance, has precisely the right strength to allow complex chemistry without tearing atoms apart or letting them collapse. Gravity is exactly weak enough to permit stars to form slowly, burning steadily for billions of years, rather than instantly collapsing or never condensing at all. Change any of these values even slightly, and you get a universe that can't support complexity. Perhaps no atoms form. Perhaps stars never ignite. Perhaps everything collapses back on itself in moments, or expands so rapidly that matter never clumps into anything interesting. We exist in what seems like an impossibly narrow corridor of possibility, and that raises the most foundational question of all. Why is there something rather than nothing? And why this particular something, with these specific rules? Building on this sense of improbable precision, we might turn our attention to the laws themselves, those strange mathematical relationships that govern absolutely everything. When scientists describe the universe, they use equations, not because reality is somehow mathematical, necessarily, but because mathematical relationships seem to capture how things actually behave. The strength of gravity between two objects follows an inverse square law. Energy and mass are related by a precise constant. Quantum particles obey probability distributions that can be mapped with exquisite accuracy. What's peculiar is how universal these laws appear to be. We can observe galaxies billions of light years away, looking at light that left them when the universe was young, and the same equations still apply. The speed of light appears constant. The charge of an electron seems identical. The mathematical structure holds across distances and times that dwarf human comprehension. These aren't approximations or rough guidelines. They're precise, often to many decimal places. The fine structure constant, which helps determine the strength of electromagnetic interaction, is approximately 1137, not 1136 or 1138, but right there, consistently measured the same way everywhere we look. No one decided these values. We discovered them, the way you might discover which key fits a lock. They were already true before humans existed, before Earth formed, before the first stars ignited. They seem to have been true from the earliest moments we can trace. This raises something philosophers call the problem of natural law. Laws in human experience are rules that someone creates. Speed limits exist because lawmakers established them. Mathematical theorems exist because they follow from axioms someone defined. But physical laws? No one wrote those, they simply are. Or are they? Some thinkers have wondered whether these laws might be more like descriptions than prescriptions, our way of capturing patterns that emerge from something deeper. Maybe the universe doesn't obey laws the way citizens obey traffic regulations. Maybe the laws are just our labels for what happens when more fundamental principles play out. But what would those more fundamental principles be? And where would they come from? Here's where the question starts to open outward. If the laws of physics just exist, we can ask, why these laws? Why this set of rules and not another? The question feels almost childlike in its simplicity, yet it cuts straight to the foundation of reality. On one hand, maybe the laws are necessary. Maybe there's only one way a universe can be, and we've discovered it. On the other hand, maybe these laws are contingent, selected from infinite possibilities by some process or principle we haven't identified yet. And if they were selected, what did the selecting? What determines that the electromagnetic force has this strength, that the cosmological constant has that value? Did these values simply crystallize randomly at the universe's beginning, or might they reflect some kind of external constraint, some generative principle operating from beyond the system itself? The precision feels too specific to be arbitrary, yet we have no clear explanation for why it couldn't be arbitrary. We exist in what appears to be a finely tuned instrument, but we don't know if there was a tuner, or if we're simply noticing the tuning because we couldn't exist in a universe tuned differently. The laws themselves are silent on their own origins. From these timeless laws, we can trace backward to a beginning, or at least to what appears to be a beginning. The evidence is written everywhere. Galaxies are racing away from each other, the space between them expanding. If we run this expansion backward, like rewinding a film, everything converges to an incredibly hot, dense state roughly 13.8 billion years ago. This is what we call the Big Bang, though the name is almost comically inadequate for what it represents. We can still detect the afterglow of this beginning. The cosmic microwave background radiation fills all of space, a faint whisper of heat left over from when the universe was young and opaque, before atoms had formed, before light could travel freely. This radiation matches theoretical predictions with unsettling precision, supporting the story our equations tell. It's tempting to imagine the Big Bang as an explosion in space, like a firework bursting. But it wasn't that. Space itself expanded. There was no outside for it to expand into, at least not in any spatial sense we can visualize. The universe didn't grow into a pre-existing void, rather, the void itself grew, carrying matter and energy along with it. This is already difficult to hold in mind. We're used to things expanding into something else. A balloon expands into the air around it. A city expands into surrounding countryside. But the universe, it expands into itself? Into nothing. into something we don't have words for? And what came before? Our equations break down as we approach the initial moment. The density becomes infinite, the temperature becomes infinite, and our mathematical tools fail. We call this a singularity, a point where the physics we understand simply stops working. It's less an answer than a sign saying beyond here, we cannot see. Some cosmologists suggest that time itself began with the Big Bang. There is no before because time is part of the universe, and the universe began then. Asking what came before is like asking what's north of the North Pole. A category error based on misunderstanding the structure of the territory. But that explanation, while logically sound, doesn't quite satisfy the wondering mind, does it? Even if time began with the universe, we can still ask, why did it begin? What catalyzed this sudden eruption of space, time, matter, and energy from a state where none of those things existed? Or did they exist in some form we can't recognize? Was there something, some substrate, some potential, some generative principle that gave birth to our universe's particular arrangement? The Big Bang might describe how the universe unfolded, but it doesn't explain why there was anything to unfold in the first place. It pushes the mystery one step back to a moment before moments existed and leaves us wondering what kinds of conditions or causes could operate outside of time and space. Perhaps the universe emerged from quantum fluctuations in a pre-existing vacuum. Perhaps it's one bubble in an eternal process of cosmic generation. Perhaps it was created by some external mechanism we can barely conceive of, or perhaps the question itself is flawed, built on assumptions about causation that don't apply at such fundamental levels. The beginning we trace is real, the evidence is overwhelming. But a beginning isn't the same as an ultimate origin. It might be just another transition, another phase in a process vaster than we imagine. Every answer we find seems to birth new questions, especially when we push toward the boundaries of explanation. Consider what happens when we try to extend our understanding beyond the observable universe, or before the Big Bang, or into the quantum realm at the smallest scales. We arrive at what physicists call singularities, points where our equations produce infinities, where our models break down, where the map we've been following simply ends. At the heart of a black hole, general relativity predicts infinite density and zero volume. At the Big Bang, the same. These infinities aren't real features of the universe. They're signs that our theories are incomplete, that we've reached the edge of what our current frameworks can describe. When quantum mechanics meets gravity, our two most successful theories become incompatible. Quantum mechanics describes the very small with probability and uncertainty. General relativity describes the very large with smooth, continuous space-time. Both are spectacularly accurate within their domains, yet they speak different mathematical languages and reach different conclusions when applied to the same extreme situations. This incompatibility suggests something deeper is going on, some more fundamental description that would make both quantum mechanics and general relativity emerge as approximations, the way Newtonian physics emerged as an approximation of Einstein's relativity. Some call this hypothetical framework quantum gravity. Various approaches exist: string theory, loop quantum gravity, causal set theory, each attempting to describe reality at the Planck scale, about 10 malud 35 meters, where both quantum effects and gravitational effects become equally important. At this scale, space and time themselves might dissolve into something more fundamental. Perhaps space-time is emergent, arising from deeper quantum interactions the way temperature arises from molecular motion. Perhaps the smooth continuum we experience is actually a foam of quantum fluctuations, bubbling with virtual particles and temporary geometries. But here's what's remarkable. Even if we discover that framework, even if we successfully marry quantum mechanics and gravity, we'll still face deeper questions. We'll still ask why that framework, why those particular mathematical structures. What determines the rules that govern the rules? Science proceeds by finding patterns, then finding deeper patterns that explain the first patterns. We discovered that objects fall because of gravity. Then we discovered that gravity arises from the curvature of space-time. Perhaps we'll discover that space-time arises from something even more fundamental. But at each level, we can ask, why this pattern? Why not another? It's like peeling an onion. Each layer removed reveals another layer beneath, and we have no clear indication that we'll ever reach a final layer, a bottom turtle, a foundation that needs no further foundation. Some philosophers suggest there might be an infinite regress, explanations all the way down, forever. Others propose that explanation must eventually become circular, with fundamental principles justifying each other in a loop. Still others wonder if there might be a stopping point, some brute fact about reality that simply is, requiring no further explanation. Or perhaps, and this is where our central question begins to whisper more insistently, perhaps the foundation lies outside the system we're examining. Perhaps the universe's rules and initial conditions were set by something external to the universe itself, something operating according to principles we haven't even begun to imagine. The edges of our explanation might not be failures of science, but indicators of actual boundaries, signposts pointing beyond the territory we can map from within. Among the various ways people have wondered about external generation, one has captured particular attention in recent years: the simulation hypothesis. The basic idea is strangely simple. If consciousness can arise from computational processes, and if technology continues advancing, then eventually some civilization might create simulations detailed enough to contain conscious beings. Those simulated beings would experience their reality as real, unaware they're patterns in some vast computer. If this is possible even once, then it becomes possible many times. An advanced civilization might run millions or billions of simulations, each containing countless conscious entities, which raises an interesting question. If simulated conscious beings vastly outnumber real ones, what are the odds that we're among the real ones? This isn't meant to provoke anxiety, it's simply one angle from which to approach our central question. If our reality is a simulation, then it's generated from outside, by something beyond the system we can observe. The outside would be whoever or whatever is running the program. Some point to quantum mechanics as potential evidence. The way particles exist in probability states until observed, then collapse into definite values. This almost resembles computational efficiency, rendering detail only when needed, like a video game that doesn't fully process areas outside the player's view. The speed of light might be a processing speed limit. The Planck length might be the resolution limit, the smallest possible pixel. The mathematical nature of physical laws might reflect underlying code. These parallels feel intriguing, even if they're not proof of anything. But let's hold this lightly. The simulation hypothesis is one lens, not a conclusion. It's a modern framing of an ancient question. Might our reality be secondary to some other, more fundamental reality? Plato imagined prisoners in a cave, seeing only shadows of true forms. Hindu philosophy speaks of Maya, the veil of illusion that obscures ultimate reality. Descartes wondered if an evil demon might be deceiving him about the existence of the external world. The simulation hypothesis updates these old wonderings with contemporary metaphors. What's valuable isn't whether we're literally in a computer simulation. What's valuable is the recognition that reality might have layers, that what we experience directly might emerge from something more fundamental operating according to different principles. If our universe is substrate independent, if consciousness and physical laws could run on different underlying platforms, then the nature of that substrate becomes a profound open question. Are we patterns in a quantum field, in a computer, in some mathematical structure, in a mind, in something we don't have concepts for yet? The simulation hypothesis reminds us that external generation doesn't necessarily mean creation in a traditional sense. It might mean instantiation, implementation, rendering. The universe might be a process running on some platform, generated continuously by something outside its own framework. The multiverse idea comes in several flavors, each arising from different areas of physics, and each suggesting different kinds of external generation. Quantum mechanics suggests another kind of multiplicity. Every quantum measurement that could go multiple ways might actually go all ways, with the universe splitting into separate branches for each outcome. You measure an electron's spin, and the universe branches. In one branch you see spin up, in another spin down. Both are equally real, just causally disconnected from each other. String theory, attempting to unify quantum mechanics and gravity, predicts a vast landscape of possible universes, perhaps 10,500 different possible configurations. Each point in this landscape represents a different possible universe with different physical laws. Our universe occupies one point, but many other points might be instantiated somewhere, somewhen. This is admittedly strange to contemplate. Our minds are built to navigate spatial relationships. We think in terms of containers and contents, insides and outsides, here and there. Trying to conceive of outside without spatial separation feels like grasping at something just beyond our conceptual reach. Perhaps mathematical structures provide a clearer analogy. Consider the relationship between mathematical truths and physical reality. Mathematical theorems don't exist somewhere in physical space. The Pythagorean theorem isn't located at some cosmic coordinate, yet it seems to have a kind of reality. It was true before humans discovered it. It would remain true if humans disappeared, and it applies everywhere in Euclidean space. Is mathematics ontologically prior to physics? Does the physical universe emerge from or depend on mathematical structures that exist independently? If so, those structures would be outside the universe in the sense of being more fundamental, even though they're not spatially located anywhere. How does this happen? How can mathematical abstractions, invented by minds for intellectual play, turn out to be the deep structure of reality? One answer is that we're not inventing mathematics at all, we're discovering it. Mathematical truths might exist independently of human minds, timelessly in some platonic realm. Circles were perfectly round before anyone drew one. Prime numbers had their properties before anyone counted. The mathematical landscape existed complete and eternal, and we simply explore it piece by piece. If this is true, then perhaps physical reality emerges from or is constrained by these pre-existing mathematical structures. The universe might be, in some profound sense, a mathematical object. Its laws might not be arbitrary rules imposed on formless stuff, but rather the logical consequences of inhabiting a particular mathematical structure. And that consciousness, yours, mine, everyone's, might be less like a product of the universe and more like a clue about what the universe fundamentally is. Alongside mathematics and consciousness, there's another candidate for the fundamental nature of reality: information itself. When you look around your current environment, you see objects, furniture, walls, perhaps a window showing the world outside. These appear solid, tangible, made of matter, but modern physics suggests something stranger. Matter is mostly empty space. Atoms are tiny nuclei surrounded by probability clouds of electrons. Between particles, there's essentially nothing. John Wheeler, the physicist who coined the term black hole, proposed it from bit, the idea that every physical quantity, every it, derives from binary choices, from bits of information. Ask enough yes or no questions about a system, and you've completely specified its physical state. Perhaps reality is built from questions and answers, from distinctions and specifications, from information all the way down. This view connects intriguingly to our question about external generation. If the universe is fundamentally informational, then what maintains this information? What processes it? What determines which informational states are actual versus merely possible? In our everyday experience with information, there's always a substrate. Computer data exists in patterns of electrical charge, magnetic orientation, or optical properties. Books contain information in ink patterns on paper. Brains store information in synaptic connections and neural activity patterns. Information always seems to require something physical to instantiate it, but perhaps that's backwards. Perhaps what we call physical substrates are themselves patterns of information, and the fundamental substrate, the true outside, is pure information processing without needing anything physical to run on. This is where the simulation hypothesis returns, but in a more subtle form. Not necessarily that we're in someone's computer, but that the universe operates like computation, information being processed according to rules, states being transformed, patterns emerging and evolving. The laws of physics might be algorithms, space and time might be organizational structures for information, Causation might be information flow, reality might be a self-sustaining informational process, or it might be computation running on some external substrate we can't directly perceive. Quantum entanglement adds another layer of mystery. When particles become entangled, measuring one instantly affects the other, regardless of distance. No signal passes between them, at least not through space, but information about their correlated states exists in their relationship. This suggests that information might be more fundamental than the space and time we think contains it. The information perspective doesn't give us answers, but it gives us a new vocabulary for asking questions. Instead of asking what our universe is made of, we can ask, what information does it embody, and where does that information come from? Staying with fundamental questions about reality's nature, let's turn to quantum mechanics itself, perhaps the strangest and most successful theory we've ever developed. The quantum vacuum, supposedly empty space, actually seethes with virtual particles, pairs of matter and antimatter that flash briefly into existence before annihilating, energy borrowed from uncertainty, paid back so quickly that conservation laws aren't violated. This empty space has energy, has structure, has activity, so even nothingness isn't really nothing. The quantum vacuum is something, governed by quantum field theory, subject to physical laws. It's not an ultimate foundation, but another layer requiring explanation. The third option would make our universe necessary after all. Perhaps what seems contingent and fine-tuned to us reflects necessary relationships we don't yet understand. Perhaps the constants are mathematically related in ways that make them inevitable, like how certain mathematical constants emerge necessarily from axioms. But this pushes the question back again. Why those mathematical relationships? Why that axiom system? Even if our universe's properties follow necessarily from deeper principles, we can ask whether those principles are themselves necessary or contingent. Some philosophers embrace an infinite regress, contingent things explained by contingent things forever. Others accept brute facts, things that just are, requiring no further explanation. Still others insist on terminating in necessity, something that exists and acts by its own nature, needing nothing beyond itself. What's remarkable is how this ancient philosophical question connects to cutting-edge physics. When cosmologists ask why the cosmological constant has the value it does, or why there are 3 dimensions of space, they're encountering the necessity-contingency question in scientific form, and perhaps the answer matters less than the asking. Whether the universe is necessary or contingent, whether it requires an external generator or not, the mere fact that we can ask these questions, that we can conceive of the universe not existing or existing differently, reveals something about our position within reality. We're beings who can step back from existence itself and ask why. And that capacity for wonder, that drive to understand, might be as profound a mystery as the universe it contemplates. Having considered whether the universe was necessarily or freely generated, we can ask, does it require continuous sustaining, or did it begin and then continue on its own? Imagine 2 scenarios. In the first, a clockmaker builds a clock, winds it up and walks away. The clock continues ticking, following the laws of mechanics, requiring nothing further from its maker. In the second, a musician plays a note. The note exists only while the musician sustains it, ceasing the moment the breath or bow stops. Is the universe more like the clock or the note? The clockwork universe was a common metaphor in the Enlightenment. God, or whatever external source created the universe, established its laws, set the initial conditions, and then stepped back. The universe continues according to natural law, deterministic and self-sufficient, requiring no further intervention. This deist picture has appeal. It seems to respect both the transcendence of the external source, which doesn't need to meddle constantly, and the integrity of natural law, which operates consistently without interference. Science can proceed studying the mechanisms without worrying about unpredictable external tinkering, but modern physics complicates this picture. The quantum vacuum constantly seethes with activity. Virtual particles flash into and out of existence. Fields permeate all space, maintained by what exactly? Energy is conserved, but that doesn't explain why there's energy to conserve. Matter persists from moment to moment, but persistence itself might require explanation. Classical physics treated existence as inert. Things continue existing because nothing stops them, but quantum physics suggests reality is more dynamic. Particles are probability waves that must collapse continuously. Fields must maintain their values. Space itself has energy and structure that must be sustained. Some philosophers argue that existence at any moment requires a sustaining cause. Even if the universe has always existed, it needs something to ground its existence right now, to make actual rather than merely possible. Without this sustaining presence, reality would simply cease, not because something destroyed it, but because nothing maintains it in being. This is different from temporal causation. It's not that the sustaining source acts first and then the universe exists. It's that the source and the sustained are simultaneous. The way a candle flame is simultaneous with the candle burning, or music is simultaneous with the musician playing. If this is right, then the external generator isn't primarily past tense, something that created the universe long ago. It's present tense, something that sustains the universe right now and always. Generation is continuous, like a fountain flowing rather than a builder finishing. This connects to the emanation model we discussed earlier. Emanation is inherently continuous. The sun doesn't radiate light once and then stop. It pours forth photons constantly. If the universe emanates from its source, then that emanation is ongoing, sustained presence rather than completed action. What would it mean practically for the universe to be continuously sustained? Perhaps the laws of physics are better understood as habitual patterns maintained by the external ground of being, rather than independent, freestanding rules. Perhaps quantum wave function collapse represents moments of continuous creation, where possibility is repeatedly crystallized into actuality by an external selector. Or perhaps we're misunderstanding the question. If time is part of the universe, then continuous sustaining doesn't mean sustaining across moments. It means the entire timeline, all moments together, is sustained as a whole. The external source grounds the four-dimensional block universe, making the whole thing actual rather than merely possible. From within time, this might feel like moment-by-moment sustaining, but from outside time, it's a single, eternal act of sustaining, undivided and complete. None of this can be proven, of course. We can't observe outside the universe to see if there's a sustaining presence. We can only note that the universe's existence from moment to moment might not be self-explanatory, that persistence could require grounding just as much as beginning does, and there's something quietly profound about imagining that existence is actively sustained rather than merely inertial. It suggests that reality is not abandoned by its source, not set in motion and left to tick down. It suggests presence, attention, continuous creative engagement, even if we can't detect it directly. Whether this presence is conscious, intentional, personal, those are further questions. For now, we're simply noting that generation might be better understood as present continuous tense rather than past complete. Not was created, but is being sustained, always and now. Our final question in this chapter addresses perhaps the most human concern of all. Does external generation imply purpose? If something outside the universe generates it, does that generation have intention behind it? Was the universe made for something, toward something, or is generation purposeless, a mechanical or natural process without teleological direction? Purpose is something we know intimately. You're listening to this right now for a purpose, perhaps to relax, to learn, to help yourself sleep. Human actions are saturated with purpose. We do things for reasons, toward goals, with intentions, but we can't assume the universe shares this structure. Rocks don't fall purposefully, they fall because of gravity. Rivers don't flow toward the ocean intentionally, they follow gradients of potential energy. Natural processes can appear purposeless, simply following physical law without aim or intent. Yet the universe also displays what looks like directionality. Complexity increases over time. Simple particles form atoms, atoms form molecules, molecules form cells, cells form organisms, organisms develop consciousness, this increasing complexity in organization seems to point somewhere, even if we can't say where. Evolution is sometimes invoked here. Natural selection produces apparent purpose. The eye is for seeing, the heart for pumping blood, without requiring actual intention. Function emerges from competition and reproduction over vast timescales. Perhaps cosmic evolution operates similarly, generating apparent purpose without actual teleology. But evolution requires specific conditions: replication, variation, selection. These conditions exist within the universe, but do they apply to the universe as a whole? Can universes replicate and compete, with those better at producing complexity out-surviving those that don't? Some versions of multiverse theory suggest exactly that. Lee Smolin proposed that black holes might spawn new universes with slightly varied constants. Universes better at producing black holes would have more offspring, and stars are black hole factories, so universes get naturally selected for producing stars and the complexity that enables them. This is speculative, brilliant speculation, but it shows how directionality might emerge without external purpose. The universe might generate complexity because that's what systems do when given energy gradients and time, not because anyone intended it to. On the other hand, the fine-tuning we keep returning to feels purpose-laden. The constants aren't just sufficient for complexity, they seem optimized for it. The universe appears finely calibrated to permit stars, planets, chemistry, life, consciousness. This precision suggests intention, design, purpose, or does it? The anthropic principle reminds us that we can only observe universes capable of producing observers. If we exist necessarily in a universe fine-tuned for our existence, then the apparent purposefulness might be observation selection bias rather than actual purpose. But the question runs deeper. Even if our existence explains why we observe these particular constants, it doesn't explain why any universe exists at all, or why the space of possible universes is structured such that some permit complexity while others don't, and consciousness adds a wrinkle. If consciousness is fundamental rather than emergent, if it's woven into reality's structure, then the universe generating conscious beings isn't an accident. It's reality becoming aware of itself, which might be the point of the whole exercise, if point is the right word. Various philosophical and religious traditions propose different purposes for existence. Some say the purpose is love, the external source generates reality as an expression of love, or to create beings capable of loving. Some say the purpose is experience, reality exists so that consciousness can know itself through the multiplicity of experiences. Some say the purpose is becoming, reality evolves toward greater complexity, consciousness, and unity. Others insist purpose is a human category we project onto an indifferent universe. Meaning, in this view, is something we create, not something we discover. The universe has no inherent purpose, it simply is, and we generate our own significance within it. Perhaps both can be true. Perhaps the universe has no specified purpose, no detailed plan for what should happen, but has general directionality toward complexity, consciousness, and creativity, like giving someone a canvas and paints without dictating what they should paint. The purpose is the creating, not any particular creation, or perhaps purpose operates at multiple levels. The external generator might have purposes we can't fathom, while we create our own purposes within the reality we inhabit. Our meaning-making isn't false just because the cosmic purpose differs from our personal ones. What feels certain is this: whether or not external generation implies cosmic purpose, it doesn't remove our need to create meaning. We still must decide how to live, what matters, how to treat each other. The universe's purpose, if any, doesn't dictate ours, and perhaps that's the most important realization. Even if we're generated by something external, we're not puppets. We have agency, creativity, the capacity to shape our corner of reality. External generation might provide context, but it doesn't write our script. As we shift from conceptual exploration to evidence, we return to what might be our strongest clue: the remarkable fine-tuning of physical constants. The cosmological constant, which determines the universe's expansion rate, appears to be tuned to approximately 120 decimal places. If it was slightly larger, the universe would expand so rapidly that galaxies couldn't form, slightly smaller, and the universe would have collapsed back on itself shortly after the Big Bang. The narrow range permitting a long-lived, structure-forming universe is vanishingly small. The ratio between the electromagnetic force and the strong nuclear force determines whether stable atoms can exist. Adjust it by a few percent either way, and chemistry becomes impossible. Stars couldn't fuse the elements necessary for life. Complex molecules couldn't form. Gravity's strength relative to other forces must fall within tight bounds. Too strong, and stars burn out too quickly for planets to form and life to evolve. Too weak, and stars never ignite at all, remaining cold clouds of hydrogen. The mass difference between protons and neutrons seems arbitrary. There's no known reason it should be what it is. Yet if protons were slightly heavier, they'd decay into neutrons, and atoms couldn't exist. If neutrons were lighter, nuclear fusion would produce only helium. No heavier elements, no chemistry, no life. These aren't isolated coincidences. They're a web of interlocking fine-tunings, each necessary for a universe that can support complexity. Change any of them significantly, and you get a barren cosmos, all hydrogen or all black holes, or a brief flash followed by eternal expansion or immediate collapse. Three responses to this fine-tuning have emerged. First, design. An external intelligence deliberately set these constants to permit life and consciousness. The precision reflects intentionality. We're here because someone wanted us here, or at least wanted a universe capable of generating beings like us. This explanation has obvious appeal. Precision suggesting purpose is a pattern we recognize from everywhere else in experience. When we find a watch, we infer a watchmaker. When we find fine-tuned constants, why not infer a fine-tuner? But the inference has challenges. Design requires a designer, and then we must explain the designer. If the designer is complex enough to fine-tune a universe, what explains the designer's complexity? We've pushed the question back without resolving it. Second, the multiverse. If there are countless universes with randomly varied constants, then some will inevitably permit complexity, and we necessarily find ourselves in one of those. The fine-tuning is explained by observation selection. We couldn't exist in an untuned universe, so of course we observe tuned constants. This explanation avoids postulating a designer, but at the cost of postulating an enormous, perhaps infinite, number of unobservable universes. It seems profligate, multiplying entities beyond what we can verify, yet it emerges naturally from some physical theories, particularly eternal inflation, so perhaps it's not ad hoc. Third, necessity. Perhaps the constants aren't free parameters but emerge necessarily from a deeper theory we haven't discovered yet. Maybe there's only one way a universe can be, and we've discovered it. The apparent fine-tuning reflects our ignorance of the underlying necessity. This would be elegant. No need for designers or multiverses, just physics we don't understand yet. But it raises the question, why would the necessarily true physics be life-permitting rather than sterile? If only one set of constants is possible, we're lucky it permits us. Holding these three explanations lightly, without demanding certainty, we might notice they're not entirely mutually exclusive. There could be a multiverse generated by an external source according to necessary principles. The design, multiplicity, and necessity perspectives might each capture part of a fuller picture. What the fine-tuning definitely suggests is that our universe's hospitality to complexity isn't trivial. It's striking, remarkable, worthy of explanation. Whether that explanation is an external fine-tuner, a vast multiverse, or undiscovered necessary laws, the fine-tuning points beyond itself, inviting us to wonder about the context in which our universe exists. And perhaps that's enough? Perhaps recognizing that our existence is improbable, that the conditions permitting us are precise and delicate, can fill us with appropriate gratitude and wonder, regardless of what mechanism accounts for that improbability. Beyond fine-tuning, there's another striking phenomenon. Mathematics works unreasonably well at describing reality. In 1960, physicist Eugene Wigner wrote an essay titled the unreasonable effectiveness of mathematics in the natural sciences, he observed something genuinely mysterious. Mathematical structures invented for abstract, purely theoretical reasons turn out to describe physical reality with shocking precision. Complex numbers were developed in the 16th century to solve certain polynomial equations. No one imagined they described anything real. They involved the square root of -1, which doesn't correspond to any quantity you can measure. Yet complex numbers turned out to be essential for quantum mechanics. The Schrödinger equation, the fundamental equation governing quantum behavior, is built from complex numbers. Group theory, developed in the 19th century to study algebraic structures, seemed like pure mathematics with no physical application. Yet it became essential for understanding particle physics. The standard model of particle physics is essentially a description of symmetry groups. The particles we observe are manifestations of group-theoretic principles operating in nature. Non-Euclidean geometry was explored in the 19th century as a mathematical curiosity. What if space didn't obey Euclid's parallel postulate? Riemann developed the mathematics of curved spaces with no thought of physical application. Then Einstein realized that gravity is precisely the curvature of spacetime, and Riemannian geometry became the mathematical language of general relativity. This pattern repeats throughout physics. Mathematicians explore abstract structures for aesthetic or logical reasons. Decades or centuries later, physicists discover those exact structures encoded in nature. It's as if reality is somehow reading the mathematics textbooks. How does this happen? Why should abstract mathematical constructs, products of human imagination, correspond to the deep structure of physical reality? One answer: we're not inventing mathematics, we're discovering structures that exist independently. Mathematical truths are real in some Platonic sense, and physical reality is constrained or generated by these pre-existing mathematical structures. The universe is fundamentally mathematical, so of course mathematical reasoning reveals its nature. If this is right, then mathematics might be the external generator we've been wondering about. Not a mind doing math, but mathematical structures themselves being reality. The universe isn't described by mathematics. It is mathematics instantiated. But this raises questions. If all mathematical structures exist, why do we observe this particular one? What selects which mathematical structures become physical realities? And what does becoming physical even mean if the fundamental reality is mathematical? Another answer: observation selection. We develop mathematical tools, try them out, and keep the ones that work. Mathematics seems unreasonably effective because we don't notice all the mathematical structures that failed to describe reality. It's like saying it's unreasonable how well-fitting this glove is, after trying hundreds of gloves and keeping the one that fit. But this seems inadequate. The mathematics works too well, too precisely, often in domains far from where it was developed. It's not just that we find adequate mathematical descriptions, we find exact, elegant, unique mathematical structures that capture physical law perfectly. Einstein's field equations of general relativity are a particular tensor equation. Why that equation and not another? Maxwell's equations for electromagnetism have a specific mathematical form. Why that form? The Schrödinger equation, the Dirac equation, the equations of quantum field theory, each is mathematically unique and physically precise. A third possibility: perhaps mathematics is the language our minds use to understand patterns, and physical reality is inherently patterned. Mathematics works because it's our pattern recognition faculty operating on a patterned universe. The fit between math and physics reflects the fit between our cognitive structures and the world's structures. This is intriguing but doesn't fully satisfy. Why should our cognitive structures fit the world's structures so precisely? Evolution shaped our minds to navigate medium-sized objects at everyday speeds, yet the same mathematical reasoning that helps us throw spears accurately also describes quantum fields and relativistic space-time. Why? Perhaps all three answers capture something true. Mathematics might be both discovered it exists independently, and invented we construct formal systems to capture it. It might both constrain physical reality from the outside, as platonic structures and emerge from it as our way of describing patterns we observe. The unreasonable effectiveness might be a clue about external generation. If mathematics is more fundamental than physics, if physical reality emerges from or is selected according to mathematical principles, then the outside that generates our universe might be the realm of mathematical truth, eternal, necessary, generative. Or perhaps the fact that we can ask this question, that we can notice the correspondence between our abstract reasoning and physical reality, points to something even deeper. Perhaps mind and matter, mathematics and physics, are not as separate as we imagine. Perhaps consciousness, mathematics, and physical reality are three faces of one underlying mystery, moving from mathematics to perhaps an even deeper puzzle. Consciousness itself might provide evidence of external generation, or at least evidence that our physical models are incomplete. Right now, you're experiencing something, not just processing this information, though you're doing that too, but genuinely experiencing it. There's a subjective quality to your awareness, an inner texture that accompanies your thoughts and perceptions. Philosophers call this the hard problem of consciousness. We can imagine explaining how the brain processes information, how neurons fire, how sensory data is integrated, but explaining why these physical processes are accompanied by subjective experience, that seems to require something more. Consider color perception. When you see red, certain wavelengths of light hit your retina, activating specific photoreceptors, triggering neural signals that travel to your visual cortex, activating particular patterns of neurons. We can map all of this physically, but none of it explains why the experience of redness feels the way it does. Someone who'd never seen color could know all the physics and neuroscience of color perception and still not know what red looks like. The subjective experience seems to be something additional to the physical facts, something that can't be fully captured by third-person description. This explanatory gap has led some thinkers to propose that consciousness is fundamental rather than emergent. Perhaps it's not that complex physical systems generate consciousness, but that consciousness is woven into reality at the most basic level, and what we call our individual awareness is a manifestation of this fundamental feature. If consciousness is fundamental, then asking about the universe's external generation becomes asking about the relationship between consciousness and physical reality. Is physical reality generated by consciousness? Is consciousness generated by physical reality? Are they two aspects of something more fundamental? The measurement problem in quantum mechanics adds intrigue here. The wave function evolves deterministically until observation, at which point it collapses into a definite state. But what counts as observation? Early quantum pioneers like von Neumann suggested that consciousness might play a special role in collapsing the wave function. This isn't mainstream physics anymore, but the question hasn't been fully resolved. If observation requires consciousness, and observation determines which quantum possibilities become actual, then consciousness might play an active role in generating concrete reality from quantum potential. The binding problem in neuroscience presents another puzzle. Your brain has billions of neurons, each firing independently, yet you experience unified consciousness, a single integrated awareness rather than billions of separate micro-experiences. How do all these separate physical processes combine into one subjective viewpoint? No one has a satisfactory physical explanation for this binding. It suggests that consciousness might not be identical to neural activity. Perhaps consciousness is what neural activity correlates with, reflects, or manifests, but isn't reducible to. Some philosophers propose panpsychism, the idea that consciousness or proto-consciousness is present even in fundamental particles. A rock isn't conscious like we are, but maybe it has some primitive form of experience. Consciousness would then be a basic feature of reality, like mass or charge, not something that mysteriously emerges from complex organization. Others suggest idealism, that consciousness is primary and matter is derivative. The universe exists fundamentally as experience or mental content, and what we call physical reality is an organized structure within consciousness, not something separate from it. These views might seem wild, but they take seriously something undeniable. Consciousness exists, you're experiencing it right now, and purely physical explanations seem to leave out precisely what's most essential about it: the experiencing itself. If consciousness is fundamental or primary, then the external generation of our universe might be better understood as consciousness manifesting physical reality rather than physical processes generating consciousness. The outside might be universal consciousness or mind, and our individual awareness might be this universal consciousness localized, knowing itself through myriad perspectives. This connects to mystical traditions across cultures. The idea that individual consciousness is like a wave in an ocean of universal awareness appears in Hinduism, Buddhism, Sufism, Christian mysticism, and indigenous spiritualities worldwide. Perhaps these traditions discovered something empirically through introspection that we're now approaching theoretically through philosophy of mind. We don't need to accept any particular view, but the consciousness anomaly, the fact that subjective experience exists and seems resistant to physical explanation, might be pointing towards something important about reality's nature. It might suggest that what's fundamental isn't matter or mathematics or information, but experience itself. And if experience is fundamental, then our wondering about external generation becomes wonderfully self-referential. We're consciousness asking about what generates consciousness, experience inquiring into its own source, awareness becoming aware of its own mysterious nature. Continuing our survey of potential evidence, we turn to quantum mechanics itself, a theory so successful yet so strange that it might preserve traces of external generation. Quantum entanglement is perhaps the most famous quantum weirdness. Create two particles in an entangled state, separate them by any distance, across the room or across the galaxy, and measuring one instantly affects the other, not because a signal passes between them, but because they remain connected in some non-spatial way. Einstein called this spooky action at a distance, and thought it proved quantum mechanics was incomplete. But experiments have confirmed entanglement repeatedly. The particles really are connected. Measure one's spin, and you instantly know the other's spin, even though neither had a definite spin until measured. What's remarkable isn't just that entanglement happens, but what it suggests about the nature of space. If entangled particles are truly connected non-spatially, then space might not be as fundamental as we assume. The particles' relationship exists in some substrate deeper than three-dimensional space, and their spatial separation is less real than their entanglement. Some physicists propose that space itself is emergent. It arises from entanglement patterns in quantum information. At the deepest level, there is no space, just quantum information in relationships. What we experience as distance might be a high-level approximation of something more fundamental. If space is emergent rather than fundamental, then the outside generating our universe doesn't need to be spatially beyond it. The external source might exist in the same quantum information space our universe emerges from, just not manifest as part of our particular spatial reality. Superposition presents another puzzle. Quantum systems exist in multiple states simultaneously until observed. A photon goes through both slits at once. An electron occupies multiple energy levels. Schrödinger's cat is both alive and dead, though this is a thought experiment, not literal reality. The mathematics of superposition is clear and successful, but what it means ontologically, what's really happening, remains debated. Is superposition just our uncertainty about which state is actual? Or are all states equally real until observation selects one? The many worlds interpretation suggests all possibilities remain real, branching into separate universes. Measure a particle's spin, and the universe splits. One branch where you observe up, another where you observe down. Both are equally real, just causally disconnected. If many worlds is correct, then what we call the universe is just one thread in an ever-branching tapestry. The external generator would be generating not one reality but countless branching realities, all equally actual. But this raises the question, what determines the branching? Why does superposition collapse or branch at particular moments? Decoherence, interaction with the environment, explains when collapse happens, but not why the universe is structured such that decoherence occurs. The double-slit experiment's weirdness might also hint at something external. When unobserved, particles create interference patterns as if going through both slits. When observed, they go through one slit or the other. The act of observation seems to determine reality. Some interpretations suggest consciousness causes collapse. Others propose that observation just means interaction with a measuring device. Still others say there's no collapse at all, just branching. What's interesting for our purposes is that all these interpretations point beyond naive realism. Reality at quantum levels doesn't behave like solid, independent stuff existing regardless of observation. It behaves more like possibilities that crystallize into actualities through some process involving observation, measurement, or interaction. If reality is fundamentally probabilistic and observer-dependent, this might trace back to external generation. Perhaps the quantum substrate is where external input enters the system, where possibilities are selected or actualized by something beyond the physical universe. The vacuum energy, the energy of empty space, provides another quantum oddity. Quantum field theory predicts that empty space should have enormous energy density. Calculating this vacuum energy gives a result roughly 120 orders of magnitude larger than observed. This is called the cosmological constant problem, and it's one of physics' most embarrassing failures. Why is the observed vacuum energy so much smaller than theory predicts? Some balancing mechanism must exist. Some fine-tuning or selection process that sets the vacuum energy to its measured value. Could this selection happen externally? Could the reason our vacuum energy permits galaxies and life be that it was chosen from among possibilities by an external generator, or that we inhabit one universe among many where the value happens to work? Quantum mechanics doesn't prove external generation, but its strangeness, entanglement, superposition, observer dependence, vacuum energy, suggests our universe might not be self-contained. It might require something beyond itself to explain why these particular quantum behaviors are actual, rather than other logically possible quantum mechanics. The peculiarities feel like clues, hints that reality's fundamental level is stranger and more open than classical physics suggested. And that openness might be where external generation operates. Having surveyed potential evidence for external generation, we should acknowledge soberly, none of it constitutes proof, and perhaps proof is impossible in principle. Gödel's incompleteness theorems, proved in the 1930s, demonstrated that any sufficiently complex formal system contains true statements that can't be proven within that system. The system is either incomplete, unable to prove all truths, or inconsistent, able to prove contradictions. This mathematical result has philosophical implications. If the universe is a formal system of sorts, operating according to rules, then there might be truths about the universe that can't be proven using only observations and reasoning from within the universe. External generation might be such a truth. We exist within the universe, bound by its rules, limited to observations of its contents. If something truly external generates this system, we might be constitutionally unable to prove it from within, just as a character in a novel can't prove the novelist's existence using only evidence from within the story. The problem is methodological. Science works by observation, hypothesis testing, and revision, but all our observations are of things within the universe. Our instruments detect electromagnetic radiation, gravitational waves, particle interactions, all internal phenomena. By definition, we can't observe what's external. We can observe effects that might be caused by external generation, fine-tuning, quantum peculiarities, consciousness, but we can't distinguish definitively between external causes and internal mechanisms we haven't discovered yet. This is similar to the problem with testing multiverse theories. If other universes exist but are causally disconnected from ours, we can't observe them. We can only observe our universe and infer that multiverses might explain what we see, but the inference is philosophical, not empirical in the usual sense. Some argue this makes multiverse theories, and similarly external generation hypotheses, unscientific. If a theory can't be tested, it's not science but metaphysics. It might be interesting philosophy, but it doesn't belong in physics journals. Others argue that inference to best explanation is valid scientific reasoning. We can't directly observe electrons, or dark matter, or the Big Bang, but we infer them because they best explain what we do observe. Similarly, we might infer external generation if it best explains fine-tuning, consciousness, quantum mechanics, and mathematical effectiveness. But best explanation is tricky when multiple explanations exist. Is external design better than a multiverse? Is fundamental consciousness better than emergent consciousness? These are value judgments about simplicity, elegance, and plausibility, not empirical determinations. The observational horizons of cosmology add another limit. We can only observe regions of space from which light has had time to reach us since the Big Bang. Beyond that cosmic horizon, the universe might be completely different. Different laws, different constants, different structures, and we'd never know. This means even observational cosmology faces limits. We can't know if the laws we observe locally apply throughout infinite space. We can't know if our observable patch is representative or anomalous. The larger structure might be generating our local patch in ways we can't detect. Quantum mechanics observer dependence creates epistemological challenges too. If observation affects reality, then every attempt to study the universe changes it slightly. We can't step outside our observational relationship to reality to see what reality is like unobserved. This isn't a practical limit that better instruments could overcome. It's a theoretical limit built into the structure of quantum mechanics. And if quantum mechanics is correct, this limit is fundamental. All of this suggests that external generation might be permanently beyond proof or disproof. It might remain a metaphysical possibility, supported by philosophical arguments and suggestive evidence, but never definitively confirmed or eliminated. And perhaps that's appropriate. Perhaps the deepest questions about existence, why there's something rather than nothing, what grounds reality, whether there's external generation, are questions we can wonder about, explore, argue over, but never finally settle. This doesn't make them unimportant. The fact that we can't prove God's existence or non-existence doesn't stop the question from mattering to billions of people. The fact that we can't prove whether consciousness is fundamental or emergent doesn't stop it from being a profound puzzle worth contemplating. Maybe some questions are valuable precisely because they remain open, because they invite ongoing wonder rather than permitting closure. External generation might be one of these, a question we can live with, think about, let shape our perspective, without needing to resolve it definitively. The limits of proof might not be failures but features, preserving space for mystery, uncertainty, and the ongoing human drive to understand our deepest origins. Moving from evidence to meaning, we might ask, what does it feel like to hold this question? Does contemplating external generation offer comfort or create unease? For some, the possibility that reality is generated from outside provides profound reassurance. If our universe has a source, a ground, an external generator, then existence isn't random or absurd. There's a reason we're here, even if we don't fully understand it. The universe isn't a cosmic accident, but an expression of something beyond itself. This can feel stabilizing. When life seems chaotic or meaningless, the thought that reality emerges from something more fundamental, whether that's mathematics, consciousness, or a creative intelligence, can anchor meaning. We're not isolated in a void, but connected to something larger. The idea that consciousness might be fundamental rather than accidental can be especially comforting. It suggests that awareness, subjectivity, and experience aren't flukes of matter arranging itself accidentally. They're central to reality's nature. Your consciousness isn't an anomaly in a dead universe, but a manifestation of what the universe fundamentally is. For others, external generation creates different feelings. If we're generated by something beyond our understanding, are we real? Are our experiences valid? Does anything we do matter if we're just patterns in some external process? These worries often stem from imagining external generation in particular ways, as a simulation where we're not really real, or as deterministic creation where we're puppets without agency. But external generation needn't imply either. Even in a simulation, experiences are real to the experiencer. Love, meaning, beauty, suffering. These are genuinely felt regardless of what substrate they run on. A simulated sunset is no less beautiful to the simulated observer experiencing it. The reality of experience doesn't depend on the fundamental nature of the substrate, and external generation needn't be deterministic. If quantum mechanics is fundamental, then indeterminacy might be built into reality, or if consciousness participates in generating outcomes, then we have agency even within an externally generated framework. Being created doesn't automatically mean being controlled. Some find external generation unsettling because it seems untestable. If we can never know whether there's something beyond the universe, then what's the point of thinking about it? Doesn't it just create anxiety about unknowables? But humans have always wondered about origins. Every culture has creation stories, cosmologies, myths about where everything comes from. This wondering seems to be part of what makes us human. We're the beings who ask why, about existence itself. Perhaps the discomfort comes not from the question, but from expecting a definitive answer. If we approach external generation as a mystery to live with rather than a problem to solve, it might feel less unsettling. We can hold the question lightly, let it inform our perspective without demanding certainty. There's also something democratizing about the question's openness. Scientists, philosophers, mystics, and ordinary people can all wonder about external generation. No one has privileged access to the answer. We're all equally uncertain, equally capable of awe before the mystery. This shared uncertainty can be bonding. When we acknowledge that the deepest questions remain open, we're more likely to listen to different perspectives, less likely to claim absolute knowledge. The mystery invites humility. Different personality types will respond differently. Some need firm answers and find uncertainty stressful. Others are comfortable with ambiguity and enjoy open-ended wondering. Neither response is wrong. They're different ways of being human in the face of profound questions. What matters is recognizing that contemplating external generation can serve different existential needs. For some, it provides meaning and connection. For others, it raises questions about agency and reality. And for still others, it's simply an intellectually fascinating puzzle without deep emotional implications. How the question makes you feel might depend less on philosophical arguments and more on your temperament, your life experiences, your spiritual inclinations. And that's fine. The question is large enough to accommodate many different relationships to it. Perhaps the healthiest approach is holding it neither as absolute truth nor as meaningless speculation, but as a possibility worth contemplating. One lens among many for understanding our existence, valuable for the wonder it evokes and the humility it encourages, rather than for any answer it provides. One important thing to recognize: contemplating external generation doesn't conflict with scientific inquiry. They operate at different levels, asking different kinds of questions. Science investigates how things work. It studies mechanisms, patterns, regularities. It asks, given that the universe exists with particular laws, what follows? How do galaxies form? How does evolution produce complexity? How does the brain generate behavior? These are how questions, and science excels at answering them. External generation asks why questions. Why does the universe exist at all? Why these particular laws? Why is there something rather than nothing? These are metaphysical questions, and science doesn't claim to answer them, not because they're unimportant, but because they lie outside science's methodological scope. This is sometimes called methodological naturalism. Science assumes, as a working method, that natural phenomena have natural explanations, but this is a methodological choice, not a metaphysical claim. It doesn't assert that only natural things exist. It simply brackets that question to focus on investigating the natural world. A scientist can rigorously study physics while personally believing in external generation. Many do. They recognize that their scientific work describes how the universe operates, while their philosophical or spiritual views address why it exists and what that means. The mistake is conflating these levels. If someone says science has disproven external generation, they've misunderstood science's scope. Science can't disprove metaphysical claims about what grounds reality, because it only studies phenomena within reality. Similarly, If someone says external generation makes science unnecessary, they've misunderstood both. Even if the universe is externally generated, we still need to study how it works. Knowing a simulation exists doesn't give you the simulation's code. Believing in a creator doesn't tell you how evolution works. Historically, some of science's greatest contributors have held various metaphysical views. Newton believed in God and saw his physics as revealing divine order. Einstein spoke of God, though, in a Spinozan pantheistic sense, and wondered at the universe's rational comprehensibility. Heisenberg engaged deeply with philosophical and spiritual questions. These weren't distractions from their science, they were part of their motivation. Wondering why the universe is mathematically ordered motivated them to discover its mathematical patterns. The metaphysical questions and the scientific investigation coexisted productively. Modern physics doesn't conflict with external generation, it might even point toward it. Quantum mechanics reveals that reality is stranger than classical physics suggested. Cosmology uncovers fine-tuning and a mysterious beginning. Consciousness remains unexplained. These findings don't prove external generation, but they keep the question alive as scientifically informed speculation. Theoretical physics increasingly explores territory that feels philosophical. Multiverse theories, the nature of time, the measurement problem in quantum mechanics, the relationship between mathematics and physics, these blur boundaries between physics and metaphysics. Physicists find themselves making philosophical arguments because the empirical evidence underdetermines the theories. This doesn't mean physics has failed, it means we're approaching the limits of what empirical investigation can settle. The deeper we go, the more interpretive choices matter, and interpretation always involves philosophical assumptions. External generation can actually support scientific optimism. If the universe is externally generated by something rational, whether that's mathematical structures, a mind, or some other principle, then we have reason to expect that the universe is comprehensible, that patterns exist to be discovered, that our investigations will reveal order. Many scientists have noted this. Science assumes the universe is intelligible, but why should it be? Why should mathematical reasoning work? Why should experiments conducted here and now reveal universal laws? If the universe were truly random or absurd, science wouldn't be possible. The fact that science works might itself suggest external generation by something that makes reality rational, ordered, comprehensible. This isn't proof, but it's a consistency. What's crucial is maintaining both pursuits: rigorous scientific investigation of how things work, and open philosophical wondering about why things exist. Neither should constrain the other. Science shouldn't claim to answer metaphysical questions. Metaphysics shouldn't dictate empirical results. When held in this healthy relationship, scientific discovery can deepen our appreciation of the mystery. Every answer we find reveals new questions. Every pattern we uncover invites wonder at why that pattern exists. Science doesn't eliminate mystery. It makes mystery more precise, more beautiful, more worthy of contemplation. So contemplating external generation doesn't mean abandoning science or treating it as irrelevant. It means recognizing that science operates within a context, and wondering about that context, what grounds it, what makes it possible, what it all means, is a legitimate and complementary form of inquiry. Our question about external generation isn't new. Humans have wondered about reality's source for as long as we've been capable of abstract thought. Looking briefly at philosophical traditions can enrich our contemporary wondering. Plato, in ancient Greece, proposed that the physical world is a shadow of eternal forms. The chair you sit on is an imperfect copy of the form of chair, which exists in a realm of perfect, unchanging ideas. Ultimate reality for Plato is this realm of forms, abstract, eternal, generative of the imperfect physical world we inhabit. This connects interestingly to our mathematical speculation. If mathematical structures are Platonic forms, then physical reality might be generated by or from these eternal mathematical truths. Plato's ancient insight resonates with modern mathematical realism. Aristotle, Plato's student, disagreed. He argued that forms exist in things, not apart from them, but he proposed an unmoved mover, a source of all motion and change that itself doesn't move or change. This generative principle stands outside the causal chain of the physical world, grounding it without being part of it. Medieval philosophers like Aquinas synthesized Aristotelian philosophy with theology, developing sophisticated arguments about how the world relates to its transcendent source. Aquinas distinguished between essence, what something is, and existence, that it is, arguing that contingent beings have their existence granted by a necessary being whose essence is existence itself. These medieval arguments feel abstract, but they're grappling with our question: why does the universe exist rather than not exist? What accounts for contingent reality? The answer they proposed, a necessary, self-existent source of being, is one version of external generation. Eastern philosophies offer different perspectives. In Hindu thought, Brahman is the ultimate reality from which all phenomena emerge. The physical world is Maya, not exactly illusion, but a kind of manifestation or appearance of Brahman. Individual souls, Atman, are ultimately identical with Brahman, like waves that are fundamentally ocean. This suggests external generation not as creation by an external deity, but as emanation from an ultimate ground of being that's both transcendent and immanent. The source is both outside transcendent of the world and inside the world's deepest nature. Buddhism approaches the question differently, often refusing to speculate about ultimate origins. The focus is on understanding suffering and finding liberation, not on cosmological questions. Some Buddhist schools suggest that asking about the universe's ultimate source is like a person shot with an arrow asking about the arrow's manufacturer instead of removing it. Interesting perhaps, but not addressing the urgent problem. Yet other Buddhist traditions explore the nature of consciousness and emptiness in ways that connect to our question. If all phenomena are empty of inherent existence, what is their status? How do they exist? Some interpretations suggest they arise from the luminous nature of mind itself. Process philosophy, developed by Alfred North Whitehead in the 20th century, proposes that reality is fundamentally composed of events and processes rather than static substances. God, in this framework, isn't a being outside the world but deeply involved in the world's creative advance, experiencing it and offering possibilities for its becoming. This represents another model of external generation, not as a singular creative act in the past, but as ongoing participation in reality's unfolding, a continuous creative relationship between the divine and the world. Indigenous philosophies worldwide often don't separate the sacred from the natural, the creator from the creation. The world might be understood as dreamed into being, or sung into being, or thought into being by the divine. The boundary between internal and external, between generator and generated, becomes permeable. What's striking is how different these traditions are in their specifics, yet how they all engage with versions of our central question. Every philosophical culture has wondered about what grounds existence, what makes reality possible, whether there's something more fundamental than the world we experience. This universality suggests the question springs from something deep in human consciousness, perhaps from our capacity for abstract thought, or our awareness of contingency, or our sense that meaning must connect to something beyond the immediate and temporary. Studying these traditions doesn't give us answers, but it enriches the question. It shows us different ways of framing the wondering, different vocabularies for articulating what we're pointing at when we ask about external generation. And it reminds us that we're joining a conversation that's been ongoing for millennia, a conversation that seems to be part of what it means to be human. Given this rich philosophical heritage and our scientific evidence, we might ask, what are the main perspectives people actually hold on external generation? How do contemporary thinkers position themselves on this question? Materialists or naturalists hold that physical reality is all there is. The universe exists, governed by natural laws, and there's no need to posit anything beyond it. Consciousness emerges from matter, laws are brute facts, and the universe is self-contained. External generation is unnecessary. The universe either exists necessarily, or is simply a brute fact requiring no further explanation. This view has the virtue of simplicity and aligns well with scientific practice. It doesn't multiply entities beyond what we can observe, but it faces challenges explaining fine-tuning, usually answered with multiverses, consciousness usually said to be emergent, though the mechanism remains unclear, and why there's something rather than nothing, usually treated as a question that can't be answered, or doesn't need answering. Theists believe in a transcendent deity that created and possibly sustains the universe. This deity is external to the universe, the ultimate source of existence, conscious and intentional. Different religious traditions specify this in various ways, personal or impersonal, involved or distant, singular or multiple. This view provides clear answers to why the universe exists divine intention, and why it's fine-tuned divine design, but it faces questions about the deity's nature and origin. What explains God? Most theists answer that God is necessary, exists by nature, requires no explanation. Critics find this less satisfying than theists do. Pantheists identify God with the universe itself. The universe is divine, and the divine is the universe. They're one and the same. Spinoza famously held this view, seeing God as identical with nature. In this framework, there's no external generation because the generator and the generated are unified. This preserves religious language and feeling while avoiding supernatural claims, but it doesn't really address our question about external generation, because everything remains internal to the one reality. Panentheists propose that the universe exists within God, but God transcends the universe. God is more than the universe, but includes it. This is like how your thoughts exist within you, but you're more than just your thoughts. The universe might be God's body, or God's thought, or God's creative expression. This offers a middle way between transcendent theism and immanent pantheism. It allows for both external generation, God transcends the universe, and intimate connection, the universe exists within God. But it inherits some puzzles from both perspectives. Idealists argue that consciousness or mind is fundamental, and matter is derivative. The universe exists as or within universal consciousness. Individual minds are localized expressions of this universal consciousness. External generation in this view means the physical world is generated by mind or consciousness that's more fundamental than matter. This takes consciousness seriously as fundamental rather than emergent, which aligns with phenomenological experience. But it's difficult to test empirically and faces questions about why consciousness would generate a physical world that appears to operate independently of mental states. Agnostics acknowledge we don't know, and perhaps can't know, whether there's external generation. The evidence underdetermines the question. Multiple interpretations remain viable. Rather than committing to any, they remain uncertain, open to possibilities, but not convinced by any particular view. This is intellectually honest and avoids overconfidence, but some criticize it as fence-sitting, avoiding commitment when commitment might be warranted despite uncertainty. Mathematical realists, as we've discussed, hold that mathematical structures are real and possibly generative of physical reality. This gives a non-theistic, non-materialistic answer to external generation. Math is the external source. What's important is recognizing that intelligent, informed people hold each of these views. The question isn't settled. The evidence supports multiple interpretations. Personal temperament, philosophical inclinations, life experiences, and spiritual intuitions all play roles in which view feels most compelling. This diversity of perspectives needn't be frustrating. It can be enriching. Each view captures something. Materialism captures the success of physical explanation. Theism captures our sense of purpose and meaning. Idealism captures consciousness's primacy in our experience. Agnosticism captures our epistemic limitations. Perhaps the full truth is richer than any single perspective. Perhaps reality has layers that different viewpoints illuminate differently. Perhaps holding the question lightly while remaining open to multiple perspectives is wiser than demanding premature certainty. We can appreciate the strengths of each view while acknowledging their limitations. We can engage seriously with perspectives different from our own, recognizing that people holding them are responding to real features of reality that deserve consideration. The multiple perspectives remind us that wondering about external generation isn't just an intellectual puzzle. It's a deeply human activity of making sense of our existence, And humans bring different tools, temperaments, and traditions to that sense-making. As we near the end of our exploration, we might reflect on uncertainty itself. What if the question of external generation remains permanently open? What if mystery isn't a problem to solve, but a gift to receive? We live in a culture that values answers. Education trains us to solve problems, find solutions, reach conclusions. Uncertainty feels like failure. We haven't figured it out yet, but presumably we will someday. Mystery is just ignorance waiting to be dispelled by knowledge. But perhaps this attitude misses something important. Perhaps some mysteries are valuable precisely because they remain mysterious. Perhaps the question of external generation is one of these. When we can't definitively answer whether our universe is generated from outside, we're invited into a particular kind of humility. We can't claim to understand everything. We can't reduce reality to our concepts. There's more to existence than our theories capture, and that more might always exceed our grasp. This humility isn't weakness, it's realism. Recognizing the limits of our knowledge is more honest than pretending we know more than we do, and it opens us to genuine wonder, which requires acknowledging that we're in the presence of something that surpasses our understanding. The permanent openness of the question also preserves intellectual freedom. If we definitively knew the answer, there'd be nothing left to think about. The question would be closed, case settled, conversation over. But because the question remains open, each generation can engage it freshly, bringing new insights, new perspectives, new frameworks. This is true for individuals too. You might hold one view now and find yourself drawn to another later as you learn more, experience more, think more deeply. The question grows with you, offering new dimensions to contemplate at different life stages. Mystery also invites contemplation. When we can't solve something by thinking harder, we're pushed toward different modes of engagement: meditation, prayer, artistic expression, philosophical wonder. These aren't inferior to analytical problem solving. They're different ways of knowing, appropriate for different kinds of questions. The question of external generation might be better addressed through contemplation than through calculation. Not because it's irrational, but because it points towards something that exceeds rationality's reach even while remaining rationally approachable. There's also something democratizing about permanent mystery. Experts and amateurs, scientists and mystics, ancient philosophers and contemporary thinkers all stand on roughly equal ground before the unanswerable. No one has privileged access to certainty. We're all wondering together. This levels intellectual hierarchies in healthy ways. Yes, some people know more physics or philosophy than others, and that expertise matters. But when it comes to the ultimate question of why anything exists, we're all ultimately uncertain. The physicist's uncertainty and the child's uncertainty aren't that different in kind. Moreover, living with mystery can cultivate valuable dispositions. Patience, recognizing that not everything can be known immediately. Humility, acknowledging our cognitive limits. Openness, remaining receptive to new insights and perspectives. Comfort with ambiguity, learning to function well despite uncertainty. These are practical virtues, useful in all areas of life. A culture that embraces mystery might be better equipped to handle complexity, nuance, and situations where clear answers aren't available. The mystery of external generation also connects us to something larger than ourselves. When we wonder about the universe's source, we're participating in a human activity that spans cultures and centuries. We're joining our wondering to that of countless others who've looked up at the night sky and asked why. This connection across time and culture can be deeply meaningful. It reminds us that we're not isolated individuals, but parts of humanity's ongoing conversation with existence itself. And wondering matters because wondering is part of what makes us human. Finally, mystery invites awe. When we can't explain something, when it exceeds our categories, when it remains gloriously incomprehensible despite our best efforts, that's when awe arises. And awe, researchers have found, correlates with well-being, connection, and a sense of meaning. Perhaps the question of external generation gifts us awe. Perhaps its resistance to final answers is precisely what makes it valuable. Perhaps we should be grateful that this mystery remains, inviting us into wonder again and again, keeping us humble and curious and connected to something larger than our understanding. As we begin to draw our exploration to a close, let's return to something simple and grounding. The universe you actually experience hasn't changed because we've been thinking about its possible external generation. The stars still shine with the same light whether they're generated from outside or not. Your thoughts still arise in your awareness. Your breath still moves in and out. The texture of these words, whether you're reading or listening, remains the same regardless of metaphysical conclusions. This is worth emphasizing because philosophical speculation can sometimes feel destabilizing. We've been contemplating whether reality might be fundamentally different from what it appears, generated from outside, sustained by external sources, possibly a simulation or mathematical structure, or mental content rather than straightforward physical stuff. But your direct experience is what it is. The warmth of your bed, the darkness of the room, the quiet of night. These immediate sensations don't depend on theories about ultimate reality. They're given, present, undeniable in their immediacy. Even if you're in a simulation, the simulated coffee tastes like coffee to you. Even if consciousness is fundamental and matter is derivative, the chair feels solid when you sit. Even if the universe is a mathematical structure, mathematics manifesting as physical reality still includes the full richness of sensory experience. Philosophers sometimes worry about whether external generation makes reality less real, but reality isn't diminished by being generated. Your experiences are genuinely experienced regardless of what substrate they run on. Your relationships genuinely matter. Beauty is genuinely beautiful. Meaning is genuinely meaningful. The question of external generation is about context, not content. It's asking what framework our experiences exist within, not whether those experiences are valid, and the validity of experience doesn't depend on the framework. It's immediate, self-evidencing, given in the experiencing itself. This is liberating. You don't need to resolve the metaphysical question to live fully. You don't need to know whether there's external generation to love, create, wonder, grow. The ultimate nature of reality is one thing. Your engagement with the reality you inhabit is another. Moreover, the universe reveals itself in experience first, in theory second. Before you knew any physics or philosophy, you knew the world through seeing, touching, feeling, thinking. That primary contact with reality remains the foundation. All our theories are attempts to make sense of experience, not replacements for it. So if contemplating external generation has made reality feel abstract or distant, come back to immediacy. Notice the air on your skin, feel your body's weight, hear the ambient sounds around you. This is reality too. Not less real than quantum fields or mathematical structures, but more immediately accessible. The great gift of returning to immediate experience is recognizing that mystery doesn't threaten the given. We can wonder about ultimate origins while fully inhabiting the world as we find it. We can hold metaphysical questions lightly while engaging deeply with life's immediate richness. Perhaps this is the sanest relationship to external generation. Thinking about it enriches our appreciation of existence without displacing our direct participation in existence. The question opens us to wonder, the wonder returns us to presence, and presence grounds us in the reality we actually inhabit, however it may be ultimately explained. The universe unchanged, stars still burning, hearts still beating, consciousness still illuminating experience from within. Whatever generates all this, the result is something worth inhabiting fully, worth experiencing deeply, worth treating as genuinely real because it is real in the only way that finally matters. It's real to you, right now, given in this very moment of awareness. Whether our universe is externally generated or not, we remain in essentially the same position. Finite beings capable of infinite questions, temporary consciousnesses aware of eternity, limited perspectives trying to grasp unlimited reality. If the universe is externally generated, that doesn't make us less significant. Some worry that being created or simulated or emergent would mean we're somehow less real or less valuable. But value doesn't derive from being fundamental. Children aren't less valuable than parents for being generated by them. Novels aren't less meaningful than the minds that wrote them. What we are is what we are. Conscious beings capable of love, creativity, suffering, joy, wonder, meaning-making. These capacities don't depend on whether we're ultimately grounded in matter, mathematics, mind, or something we haven't conceived of. They're real features of our existence, however existence is ultimately structured. If anything, external generation might enhance significance in certain ways. If consciousness is fundamental rather than accidental, then our awareness participates in reality's deep nature rather than being a random fluke. If the universe is fine-tuned for life, then life isn't an unwelcome accident but somehow central to reality's character. But significance doesn't require external validation. We don't need the universe to be designed for us to matter. We matter because we're here, because we experience, because we care, because we create meaning and beauty and connection. Our mattering is self-establishing, grounded in the undeniable fact of our existence and awareness. Responsibility works similarly. Whether we're externally generated or not, we face ethical choices. We can help or harm. We can create or destroy. We can grow in wisdom and compassion or stagnate in selfishness and fear. These options don't disappear regardless of metaphysical conclusions. Some worry that if we're in a simulation, morality becomes arbitrary, just following the programmer's rules, but this misunderstands ethics. Moral obligations arise from the structure of conscious existence itself. Suffering is bad because it feels bad, not because a rule says so. Compassion is valuable because it alleviates suffering and connects beings, not because external authority commands it. Even in an externally generated universe, the ethical landscape remains the same. Beings suffer or flourish. Actions have consequences. We're responsible for our choices and their effects. The ultimate metaphysical story doesn't change the immediate moral reality, our epistemic position. What we can know also remains constant. We have limited perspectives. We can't observe everything. Our concepts might not match reality's structure perfectly. These limitations apply whether there's external generation or not. This calls for intellectual humility regardless of our metaphysical views. Materialists can't prove there's nothing beyond matter. Theists can't prove God's existence definitively. Everyone operates with some combination of evidence, inference, intuition, and faith. Recognizing this shared uncertainty might reduce the heat in metaphysical debates. What we can do is engage reality as we find it. With curiosity and care, we can pursue truth through science, philosophy, contemplation. We can create beauty through art and craft. We can reduce suffering and increase flourishing through ethical action. We can wonder about our origins while building meaningful lives. The human position is poised between the known and unknown, the finite and infinite, the immediate and ultimate. We're beings who eat dinner and contemplate eternity, who care about local kindness and universal meaning, who are fully embedded in this world while capable of imagining what might transcend it. This position doesn't change based on whether external generation is real. We're still the wondering beings, the conscious questioners, the creatures who can ask about our own existence and never quite settle the answer. Perhaps that's our particular role in reality, to be the place where reality becomes aware of itself, questions itself, wonders about itself. Whether we're generated from outside or inside, accidentally or intentionally, we're the beings who can ask. And asking might be enough, might be the whole point, might be what gives our existence its particular flavor of meaning. So we continue as we are, living, loving, wondering, creating, suffering, growing, asking questions we can't fully answer but can't stop asking. The human position, mysterious and meaningful, unchanged by our speculations about ultimate origins. While we've been wondering about external generation philosophically, science continues its empirical investigation of reality's foundations, and this ongoing research might gradually illuminate aspects of our question, even if it never settles it completely. Quantum gravity research attempts to unify general relativity and quantum mechanics. If successful, it might reveal what space-time is at the most fundamental level, whether it's continuous or discrete, emergent or fundamental. possibly providing clues about what underlies our universe's structure. String theory and its variants continue developing, exploring the possibility that fundamental particles are vibrations of tiny strings in higher dimensional space. If evidence for extra dimensions emerges, our understanding of outside the universe might become more concrete, less purely metaphysical. Cosmological observations keep improving. Better telescopes, more sensitive detectors, more precise measurements might reveal patterns in the cosmic microwave background, or the distribution of galaxies that hint at what preceded the Big Bang, or what larger structure our universe embeds within. Particle physics experiments at ever higher energies might discover new particles or forces that reveal deeper layers of reality. Each discovery typically raises new questions, but it also constrains our theories, narrowing the space of possibilities. Consciousness research continues advancing through neuroscience, philosophy of mind, and careful phenomenological investigation. While we likely won't solve the hard problem of consciousness soon, we might better understand the relationship between physical processes and subjective experience, potentially illuminating whether consciousness could be fundamental. Artificial intelligence development might shed light on substrate independence, whether consciousness and intelligence can arise from different physical implementations. If we create genuinely conscious AI, it might support the view that consciousness is more about information processing patterns than specific biological substrates. Mathematical physics keeps discovering deeper structures. As we uncover more mathematical relationships underlying physical laws, we might better understand whether mathematics is discovered or invented, whether it's Platonic or nominist, potentially addressing whether mathematical structures could be generatively prior to physical reality. None of these research programs will likely prove or disprove external generation definitively, but they'll refine our understanding of what needs explaining, what's contingent versus necessary, what's fundamental versus emergent. They'll make our wondering more informed, our speculation more constrained by evidence, and unexpected discoveries might reframe the question entirely. History shows that scientific revolutions often reveal our previous questions were ill-formed. We asked what substance light was made of. Quantum mechanics showed light isn't a substance but a quantum field excitation. We asked what the ether was. Relativity showed there is no ether. Perhaps future discoveries will reveal that external generation is similarly based on confused categories. Or perhaps they'll vindicate the question while answering it in surprising ways. We can't predict what we'll discover by definition. That's what makes it discovery rather than confirmation. What we can expect is that reality will continue to surprise us. Every time we think we've reached bedrock, deeper layers appear. Every answer breeds new questions. The universe seems to have inexhaustible depth, always more to discover, always further mysteries beneath the ones we've just illuminated. This ongoing exploration is itself meaningful. The fact that we can investigate reality, that we can probe deeper and deeper into its structure, that nature yields to patient questioning, this is remarkable. Whether externally generated or not, the universe is intelligible to inquiry, which is a kind of gift, and the exploration isn't just institutional, it's personal too. Each of us can wonder, learn, think, contemplate. The questions we've been exploring tonight are available to anyone willing to sit with them. Professional philosophers and physicists have no monopoly on wondering about existence. Your own thinking about these questions is part of humanity's continuing exploration. Every time you wonder about reality's nature, you're participating in the ancient and ongoing human conversation with existence. Your wondering matters because all wondering matters. It's how we collectively probe the mystery we're embedded in. So the exploration continues, will continue, perhaps must continue, as long as conscious beings exist. We'll discover more, understand better, frame questions more precisely. But the deepest question, why is there something rather than nothing, and where does it all come from, might remain perpetually open, perpetually inviting, perpetually pulling us toward wonder, and that might be exactly as it should be. We've traveled far together tonight, from the observable universe to philosophical speculation about what might generate it from beyond. We've considered mathematics and consciousness, quantum mechanics and fine-tuning, timelessness and purpose. We've held multiple perspectives lightly, resisted premature certainty, let mystery remain mysterious. Now it's time to let these thoughts settle, to release the questions without needing to resolve them. You don't have to carry this wondering into sleep. You can set it down gently, like placing a book on a nightstand, knowing it will be there if you want to return to it. The universe continues existing whether you understand it or not. Reality sustains itself without requiring your conscious effort. Whatever generates existence, if anything does, operates independently of your comprehension. You can rest in not knowing. You can trust the process, the unfolding, the mysterious ground of being that holds everything, including you. Your breath rises and falls automatically. Your heart beats without instruction. Your body rests and repairs itself while you sleep. All of this happens without your conscious direction, sustained by processes deeper than your awareness. You're held in existence by something. Call it biology, call it physics, call it the cosmos, call it whatever you like. You're held, and perhaps that's the deepest truth we've touched tonight. Whatever the ultimate nature of reality, you exist within it safely. You're a manifestation of existence itself, consciousness arising from the universe to know itself. You belong here. Your existence isn't an accident or intrusion, but an expression of what reality does. It becomes aware, it wonders, it experiences, so you can release your grip on understanding. You can let the questions float away like clouds. You can sink into the direct experience of being here, now, breathing, resting, gradually transitioning towards sleep. The stars are still burning in patterns that took billions of years to arrange. Quantum fields are still humming with potential energy. Mathematics describes relationships that were true before minds existed and will remain true after. Consciousness illuminates experience from within. All of this continues, vast and intricate and beautiful, whether you're awake to contemplate it or asleep to dream. If there's external generation, it's sustaining you right now. If there's not, the universe is self-sustaining, and you're part of that self-sustaining system. Either way, you're held in existence, supported, maintained, allowed to be. You can rest in that holding. Perhaps reality is generated from outside by something we can't conceive. Perhaps it emerges from mathematical necessity. Perhaps it's the dream of universal consciousness. Perhaps it's self-existent matter following natural law. Perhaps it's something none of our concepts capture. All these possibilities remain open, and that openness is okay. You don't need to choose tonight. What you can know directly is this: you exist, you're aware, you've spent time wondering about profound things, and now you're tired. These simple facts don't require external validation. They're given in immediate experience, undeniable, sufficient for now. So let yourself rest. Let the questions go. Let the universe take care of itself, as it has been doing for billions of years, as it will continue doing while you sleep. You've wondered beautifully. You've held mystery without demanding it resolve. You've stayed open and curious and humble. Now you can close that openness gently, like closing a book you've enjoyed. The story continues even when you're not reading it. The questions remain even when you're not asking them, and you can return to them whenever you wish, or you can let them be. For now, just breathe. Just rest. Just allow sleep to come when it comes, knowing that you're part of something vast and mysterious and good, whatever its ultimate source might be. The wondering has been enough. The mystery is safe to carry. And you, wondering creature, temporary expression of eternal existence, can finally, gently, let yourself drift into the peaceful darkness, held by whatever holds all things. Rest well.